Okay, so this is 4.7, number 2. We're finding m sub n to 3 decimal places with the definite integral using the indicated value of n. And so looking ahead, a is going to be 3, b is 6, and they give us that n is 6. And so we start by knowing that the interval we're looking at is 3 to 6. But what we want to do is we want to divide this into subintervals. And to do that, we're going to use that the change in x is equal to b minus a divided by the n value. So for us, that's going to be 6 minus 3 divided by 6, or 0.5. Now that we know that, we can find the midpoints. To find the midpoints, we're going to be using, at least for the first one, a plus x sub 1 divided by 2. All right, now that brings it to what the heck is our x plus 1? Our x plus 1 is equal to the very first endpoint, which is 3, plus the 0.5 we just came up with. So x sub 1 is equal to 3.5. So that's where our subinterval is. Now let's plug it in to find our first endpoint. So a is given to us as 3, plus x sub 1, which we know is 3.35, divided by 2, and that will give us 3.25. So the first midpoint for us is 3.25. Now, since these midpoints are equally apart by this 0.5, we can just add the 0.5 to find the next midpoint. And that'll give us 3.75. All right, let's add 0.5 to that. And that gives us 4.25 as our next midpoint. add 0.5 to that, and we get 4.75 as our next midpoint. Add 0.5 to that, and we get 5.25 as a midpoint, and add 0.5 to that. We get 5.75 as the last midpoint. Now you might be thinking, why am I stopping there? Because if I add 0.5 to that, it takes me to 6.25, which is past our endpoint. So that's how I knew to stop at 5.75. Now, what we want to do next is, if we were physically looking at this, we would see the rectangles based on these subintervals. But we're going to use the calculations to find the height that each of these subintervals would be at each one of these midpoints. So I'm just going to call this part 2 to kind of give you a separation. And so for the first one, we're going to be looking at f of a plus x sub 1 divided by 2. Now, we already figured that out here, and we got the value here. So basically, we're looking at f of 3.25. And we're going to substitute that in to this. So we'll have 2 times 3.25 to the third power minus 3.25, and that will give us 65.406. Remember, we're rounding to 3 decimal places. So that would be the first one. The second one, we would use our second given endpoint here. So f of 3.75. And that's going to equal, I'll go ahead and write it, but I'm not going to write it for all of them. So it would be 2 times 3.75 to the third minus 3.75. And that will give us 101.719. All right, so for our third one, we're going to look at f of 4.25. So again, if you plug and chug that in, you'll come up with 149.281. Our fourth one, we're going to plug in f of 4.75. And when you plug and chug that, rounding it to 3, you'll get 209.594. For the fifth, we're plugging in the 5.25. And that will give us 284.156. And finally, we'll plug in the 5.75. And that will give us 374.469. Okay. We are almost there. I'm going to call this part 3. This is our last part. And so to find M sub n, that equals B minus A over n times, and instead of writing it all out, I'm going to just say add the above, or I'm going to say add the part 2 calculations. I know it's not really the math way to say it, but I think it'll be easier to do. So for us, n sub n is equal to 6 minus 3 over 6, which we know is 0.5, times, and we're going to add all of these answers. So the 65.406 added to the 101.719 plus the 149.281 plus the 209.594 plus the 284.156 plus the 374.469. And so when we work that and round to 3 decimal places, we get 592.313. I hope you find that helpful.